In this video, we are going to solve systems of equations with two variables. On this first type of question, they are asking us to determine whether the ordered pair is a solution to the system. In order to be a solution, we must be able to plug it in and have it satisfy both equations. So, if I take my first equation, y equals 7x minus 28, and I plug in the values for x and y, I'm trying to find out if the y value of negative 7 is going to equal 7 times the x value of 3 minus 28. So negative 7, is that equal to 21 minus 28? And so in this case, negative 7 is equal to negative 7, so that is true. But then I have to also check the other equation. So my other equation is 2x plus 5y is equal to negative 29. Again, plugging in the given value of x and y, I'm wanting to know if 2 times the x value of 3 plus 5 times the y value of negative 7 is equal to negative 29. So 2 times 3 is 6. 5 times negative 7 is a negative 35. Does that equal negative 29? And so when I add positive 6 plus negative 35, I am left with negative 29, and that does equal negative 29. So in this case, yes, that ordered pair is a solution. Now, in the second problem, they're asking me to use the substitution method in order to solve it. Anytime you use the substitution method, you have to have one of the variables by itself, like they have on this second equation here, and then you take the value of that variable and you plug it into the other equation. So my top equation, I have an x plus 3 times a y value that's equal to negative 2. And in place of that y value, I'm going to plug in the negative 2x minus 24 from this other equation. Since they tell me y is equal to that, I'm plugging it in for the y. And from there, I simply solve for my x. So x plus, if we distribute here, 3 times negative 2x is negative 6x. 3 times negative 24 is going to be a negative 72. And then that's equal to negative 2. Combine my x's here, and I have a negative 5x. I'm going to go ahead and add 72 to both sides while I'm on that. So that is equal to 70. Divide both sides by negative 5. And in this case, my x is going to be equal to a negative 14. So that is your x. In order to find your y, you then have to plug that back into one of the two original equations. Probably easiest to plug it into this one since they already have y by itself. So y is equal to negative 2 times our x value of negative 14, and then minus 24. So negative 2 times negative 14 would be positive 28. And then when you subtract 24, we get a y value of 4. So this definitely has a solution set, and you're going to have to type it in as an ordered pair inside of this box. So x always comes first inside your ordered pair, and then y is listed second. So you're going to type that inside the box. Okay, so on the next system of equations, we're being asked to use the addition method. With the addition method, you are looking at either one of your two variables, and you want to set it up so that when you add the two equations together, they will cancel out. Now, if you look at the way it is set up right now, that's not going to happen. If I tried to add the x's, I would get a 3x. If I tried to add the y's, I would get a 5y. So you decide which variable you want to cancel. Really doesn't matter as long as you set it up so that they have opposite coefficients. So in looking at this one, I would probably go in and say, I'm going to get rid of the x's. And if that's the case, you're going to look at what coefficients they have. So right now they have a 2 and a 1. And you're going to decide what number those both go into. So they both go into a 2. So you need one of the coefficients to be positive 2 and the other to be a negative 2. Now, since the second equation already has a positive 2 here, I'll leave it alone. So what that means is I'm going to multiply the top equation by a factor of negative 2. And you have to multiply that entire equation. So my new top equation becomes negative 2x minus 4y is equal to negative 8. It's still the same equation. We've just blown up the coefficients in order to try to do this addition method. So I left my second equation as is, 2x plus 3y is equal to 7. And now we're going to add those two equations together. So what should happen on the addition method, if you've set it up correctly, is you should have one of the two variables that zero out. So negative 2x plus positive 2x is 0. If I continue on, negative 4y plus 3y is a negative 1y. Negative 8 plus 7 is negative 1. And then I'll go ahead and solve for y. So divide both sides by negative 1, and my y value is positive 1. So this has a solution. We need to also find our x value. So we're going to take that y value, plug it into either of the two equations. So I'll just take the top one. X plus 2 times my y value of 1 has to equal 4. And then solve for x. So if x plus 2 is equal to 4, and I subtract 2 on both sides, then my x value is 2. So I would say the solution set in this case is 2, 1. Okay, so finally, one more example. Again, we are trying to, it says solve with your method of choice. So if you wanted to do substitution, then you would have to take one of the two equations and get either x or y by itself. I think I'll go ahead and do the addition method again. But notice that in order to do that, you've got to have them set up the same way. So I'm going to take this top equation before I do anything else, and I'm going to move the y to the left-hand side so that they are set up the same way. And so when I do that, that top equation becomes 4x minus y is equal to negative 7. And the bottom equation was 4x minus y is equal to 6. Okay, so if I decide to go in here, since we canceled the x last time, I'll just choose the y just to be different. Notice both of their coefficients are understood to be negative 1s. So we need one of them to be a negative 1, the other to be a positive 1. Doesn't matter which one. In order to do that, one of the two equations has to be multiplied by a factor of negative 1. So I'll just do that by the top. So the top equation now becomes negative 4x plus positive y is equal to positive 7. When we add it to the bottom equation, 4x minus y equals 6. Notice what happens here. Not only do the y's cancel out like I was trying to set up, but so do the x's. So anytime both variables cancel out, that's going to be an indication that you have one of these two other answers. You're either going to have infinite solutions or no solution. So it's the right-hand side that'll decide which of the two you have. 7 plus 6 is 13. So you ask yourself, is this a true statement? And if it is not, as it is in this case, if it's false, that is an indication that there is no solution to this system. So the answer to this particular equation is no solution. If you were to get 0 equal to 0, which would mean all of your not only your variables cancel, but so do your constants. The reason that happened is because the two equations are the same line. So if you get 0 equals 0, then that is an indication that you have infinitely many solutions. And that is the second case listed there. And so in that case, they would say that your solution set is all of the ordered pairs that are on either equation of the line. So notice they'd either give the original top equation or they'd give the original bottom because they're the same line.